it's when you're looking at a function, you think something's gone wrong. There's a couple of questions you want to ask yourself to see whether there's something actually is wrong, or there is something that we call user error. Okay, so think about when you're kind of thinking about when you're debugging a function, you want to answer all these questions as you're going through your process here. So what was the input that you put? What did you feed into that function? Okay, not what you thought you fed into that function. What did you actually feed into that function? Okay, so I thought I'd fed that function a positive number, but in reality I fed it a nan, right? So how did you call the function? What were the arguments that you gave it? Things like that. What were you expecting? And this is important when you're asking someone for help or you're asking someone a question. It's not that useful to say, oh, the print message to function didn't work. How do you know it didn't work, right? And then you say, well, I was expecting this, but I got that. Okay, that's how you know it doesn't work. And then someone could say, well, you shouldn't have expected this because that's not what that function does, or something like that. Or they can say, okay, here's the problem. So what were you expecting is very important to be able to articulate, at least to yourself and maybe to other people. What was the output that you were expecting? Were you expecting some message that you didn't get, or other results, other numerical results, things like that? So what were you expecting? And then, of course, what did you actually get? How did what you actually get differ from what you were expecting? And then, of course, were your expectations correct in the first place? So if you were expecting something that was in fact incorrect, then your notion of what is correct and incorrect is now being challenged, right? So, and then another key aspect of debugging, of course, is that you have to be able to reproduce the problem, right? Because if you can never reproduce the problem, you'll never have a chance in figuring out what went wrong, because it only happened that one time, right? So this is very, 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 very important. And unless it's the most basic problem, then I can't even say what that would be. You have to be able to reproduce the problem, because you have to be able to show someone, this is how I created the problem. Because most people are not going to know if you just show them the output or the error message of what that means or where it came from and how you got there. Okay, so the process by which you encountered the error or the problem is very important. So you have to know how to reproduce the problem. There are some problems, and so when I was talking about, for example, in random number generation, you need to set the seed, because it may be that only under a certain sequence of random numbers that a problem occurs. And if you're not setting the seed, you will never be able to reproduce that problem, because every time you run it, it's going to be a different set of random numbers. There are other types of problems that can be hard to reproduce, but they're more complex. They usually, for example, if you're writing networking functions, so you're doing like parallel programming. Often those kinds of problems can be very hard to reproduce because they depend on activity in other machines and things like that, and you can't really reproduce that. Things that if you're getting code over the internet, if you're getting data over the internet and your code is kind of interacting with things on the web, problems there can sometimes be hard to reproduce because servers on the other side may change or whatever, and so. So you can't always freeze things in time. If there's something that's just happening on your computer, it's usually going to be easier to reproduce the problems. Only under very esoteric circumstances will it be hard to reproduce a problem on your computer. So what are the tools that R comes with to help you to debug a program, right? So there are 5 basic functions and a few associated ones that I won't talk about. But the first most basic one is the traceback function. Okay. Now, one thing I want to say is that you can get pretty far in R without using any of these functions. I worked with R for like 6 years and didn't even know these functions existed. So I'm not saying that you necessarily that you will always be using these functions, but they're actually quite handy in some cases. So the traceback function, what it does is it prints out what's called the function call stack. So typically when you call a function, you call the function, and that function calls another function, and then that function calls another function, and then you're 4 functions deep, and then maybe the error happens way down here, right? And so traceback just tells you how many function calls you're in and where the error occurred, right? And so you can try to identify where in the sequence of function calls the error occurred. Otherwise, all you know is that you called one function and an error occurred, but you have no idea, how many other functions were called underneath. So the traceback function will tell you that. And I'll give you an example. So the debug function is probably the handiest function. What it does is you give it a function as an argument, and it flags that function for debug mode. Okay, and what debug mode means that anytime you execute that function, anytime, anywhere, even if another function calls it, it will suspend execution of the function at the first line, and then you can, in what's called a browser. And I'll show you how this works. And then you can step through the function line by line. And then you can execute one expression at a time, I should say, inside the function. So you can try to pinpoint, okay, if there's a specific line of code where an error occurs, you'll be able to find out which line that is. Okay. The browser function is related to debug in the sense that you can stick the browser call to the browser function anywhere in your code, and then when that line of code gets hit, when that browser call gets hit, the execution of the function will suspend. Okay, and then you can go line by line from there. So sometimes, for example, the debug function will always start the browser right at the top of the function. But sometimes you kind of want to run through the beginning and then stop it somewhere in the middle. And so the browser function allows you to stick the browser call anywhere in your code, and then it will run the function up until that point and then suspend it. So those two are obviously related. The trace function allows you to insert debugging code into a function without actually editing the function itself. And this is handy if you're debugging someone else's code, right? So for example, there's code in a package, and then you can't easily edit the code in that package, or there's code in the base R itself, or there's something like that. And you don't want to go and edit that code because you can't find the file or whatever. So you can use the trace function, just insert a little snippet of code. And usually that snippet is just the call to the browser function. And then you can kind of browse through that function, and then you can turn the trace off, and the function's back to normal. So and then the recover function is the last function. It's actually, I should put it up here. It's related to the traceback. What recover does, so normally when you get an error, you usually get a message saying what the error was, and then the console kind of comes back to you, and then you can just enter more commands. You can do whatever you want, but execution of that function stops, and you get the console back. That's the default behavior. You can change that default behavior by creating what's called, or setting what's called an error handler. And recover is an error handler function, which means that anytime you encounter an error anywhere in a function, rather than getting the console back, the R interpreter will stop the execution of that function right where the error occurred. And it will kind of freeze it there. And then it will print out the function call stack, so you'll see kind of how far deep you're in. And then you can kind of jump around to the different function calls to see and to look around. Now you're in the browser, and you can look around to the different function calls to see kind of, okay, well, what happened here and what happened here? How did the data get corrupted here? Things like that. That's a little hard to talk about in the abstract, so I'll give you an example. So these functions kind of allow you to pick apart the lines of code and try to figure out, okay, nail down where exactly the bug may be. You can also just put things like print and cat statements in your code to print out things. So if you want to know, well, what's the value of x at line 42, you can just print it out, right? And then you see what it is. And you can get a lot of mileage out of just putting in print statements. The only problem with print statements and things like that is that often you'll put in like a lot of if it's a long piece of code, you'll put in like 40 print statements. And then you're like, okay, I'm ready to go. And then you gotta go back through and like delete all the print statements. Right? So that can be a little bit kind of a pain, but there's nothing inherently wrong with it. Some people that I've worked with are actually they're like opposed to the use of debugging tools. I remember I was at a software engineer company many years ago, and there was an engineer there who was he was opposed to any debugging tools. He never used the debugger. All he did was print statements basically, because he thought that the use of the debugger encouraged bad habits. Right? So and it's true. I've seen it happen in other places where you just write some code. I don't care how it's going to work, and it's going to run it. If there's a problem, I'll just run it through the debugger, right? And I'll just step through line by line, find out what the problem was, and it encourages kind of a sloppy code development process because you know that if there's a problem, you can just step through execution with the debugger. And I have to say that is probably not a good habit to get into. It's probably better to think about your code, write it in a kind of intelligent way, and then if there's a problem, you can resort to the debugger. But I use the debugger all the time. I use the browser function. I use all these functions all the time. So Maybe I just have bad habits, but that memory is burned in my brain for some reason.